Good morning again. So last time we were in chapter 7. That is taking us from the smaller system, the 16F874A controller, to the 16F877A controller, showing us what were the common things in the architecture and how this move from smaller to larger systems made the program memory look different. So we started seeing program memory pages, and we talked about how to move between these pages and how to manipulate the program counter. And we looked at the data memory and the data memory banks, we call them. In 8.4a, we had 2 banks. Now we have 4 banks, more memory. And the last thing we were at is the interrupts. If you remember, the 16F874A controller had 4 interrupts, only 4 interrupts. Timer 0 overflow interrupt. These are the 4 interrupts. We used to have a structure like this. This was timer 0 overflow interrupt, and it had an interrupt flag and interrupt enable. External interrupt had a flag and enable. Port B change had a flag and enable. And all these flags and enables were in a register called intcon. Tamam. And we had a global interrupt enable. So these are 2, 4, 6, 7. And there was an 8th bit. In the 8.4a controller, it was the E square prom interrupt enable. I think that's how we wrote it. But the flag for the E square prom was in a different register. I think it was E square con 1 or something. I forgot the actual name. But if you remember, when we did interrupts, we did example on external interrupts, times 0 interrupts. I'm not sure if we did on port B, but the same concept. But I never tried to do that on the E square prom because it's different, because the controller we're using here in our class is the 77A. I don't have physically the 8.4a controller. But you see the difference here. Now, when we looked at the architecture at the beginning of the chapter here, we see we have much more peripherals. Timer 0, but it used to be common, but timer 1 and 2 are new. The analog digital converter we covered last night is new. E square prom was there. Capture compare PWM new. Synchronous and asynchronous communication is new. Okay, so all these new things need interrupt support, and for each interrupt we need a flag to raise when the interrupt happens. The interrupt source requests a service, and we need an enable. So this is how they did the extension. They treated this bit that we use as the E square interrupt enable as they call it a peripheral interrupt enable. Peripheral interrupt enable. Okay. And comes in all the peripheral flags and enables. So the E square prom, interrupt flag, the E square prom, interrupt enable. The parallel slave port, there's something called parallel slave port, in flag and enable. The A to D flag and enable. We talked about this yesterday. Well, for those who were there. Remember when we did a go for the analog digital converter to start sampling, and we waited for that go to come back and say done. We were waiting for a bit, and we said there is an option to wait for the analog digital converter flag to raise. So we're done converting, or we can enable the interrupt and treat the result when we're back in the interrupt service routine. We have an interrupt USART interrupt flag and enable. Okay, USART is a new universal serial universal synchronous, asynchronous receiver transmitter. It's a module that is capable of doing serial communication. Okay, it has a so you can make it interrupt the CPU when it receives something through the serial input, the serial communication input. And I'm going to cover that in an extra session, the serial communication. And we talk about that, and we're going to use the interrupt. This is for the receive, that I received something. Well, when you transmitting is going to take time. When you transmit one byte of data, it is actually sending it serially, bit by bit by bit. So, okay, so it's going to take time to transmit. So do you want to keep or keep waiting for that to finish, or you want to get an interrupt when it's done? So we have an interrupt for the transmission, flag and enable. For the sync, there is another mode of communication called synchronous. It has, I mean, I2C, SPI, okay? It has an interrupt flag and enable. The capture compare PWM, we have a flag and enable, interrupt. Timer 2, Faris, I think, was asking me about timer 2 and timer 1. They have a separate timer 2 interrupt flag, timer 2 interrupt enable, timer 1 interrupt flag, timer 1 interrupt enable. They're not located in the IntCon. No, only these ones are in the IntCon. These exist in somewhere else. Okay, I'll talk about where this is something, this other place. CCP, there are 1 and 2, capture compare PWM 1, module 1, and 2, they have also a flag and enable. Bus collision for a peripheral, we're not going to cover. It has an interrupt capability. A comparator, we have a hardware comparator to compare voltages. It has also a flag and enable. Now, all these flags and enables to serve all these interrupts. See how many interrupts, new interrupts here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 plus 4, plus 3 here. So 15 interrupts. So 84A had 4 interrupts while this had 15. Okay. Now to enable, let's say, the analog to the timer 0 flag, the timer 0 overflow interrupt. What did we enable? We did the global enable and the timer 0 local enable. So we had to do 2 levels of enable, global and local. But if you want to use timer 2, which is exactly almost the same as timer 0, it's an 8-bit timer that comes from 0 to 255. When it overflows, it causes an interrupt. Okay, it has its own clock. If we want to make this timer 1 or timer 2 cause an interrupt, we need to enable the interrupt. Now we have 3 levels. We need to do global interrupt enable, peripheral interrupt enable, and then this local interrupt enable, timer 2 interrupt enable. Clear so far? So all these are called the peripherals. So you need to enable them through this bit. Okay. Okay, how do I, come on, man. This is the peripheral interrupt enable, global interrupt enable, and a local interrupt enable over here. So 3 enables to make this interrupt happen. Any of these interrupts in this, on this side, in the left side. Okay. While any interrupt of the 3 here only needs the global and the local. Okay.
دكتور بس مظبوط تعيد آخر جملة صوتك علق ما كانتش واضحة.
Okay. I was saying to enable timer 0 interrupt, we had to do a global interrupt enable in the IntCon register. صح? And the timer 0 local interrupt enable. Also, بس only two enables. But this left side, من الخط هذا to the left, هذول are called the peripheral interrupts. To enable any of them, you need to do the global interrupt enable, because see this AND gate? They're all going through this AND gate. So if this is 0, whatever happens here on the left is not gonna interrupt the CPU. So you need to do a peripheral interrupt enable. So global, peripheral, then local. Okay. For these interrupts, we had two enables, two levels of enable. For these, we had three levels of enable. Okay. Is it clear now?
100 دكتور.
Okay. Now we're gonna look, try to find where these enables and flags are. These ones we know there are in a register called intcon. بس هذول وين هم هذول؟ Okay. There are two registers. What is this register? This is the intcon, huh? This is the intcon register. This is the intcon that we used to know in the 16F878A controller. And this is port B interrupt flag, external interrupt flag, timer 0 interrupt flag. The same, exactly the same. Port B interrupt enable, external interrupt enable, timer 0 interrupt enable, global interrupt enable. Hi, this one used to be the E square prom interrupt enable. I don't know how you write it. In the 16F874A controller. Now it's different here. We're in the 77A. In the 77A, this is the peripheral interrupt enable, which is this bit here. And this peripheral interrupt enable. Okay? Peripheral enable. So you have to do it before being able to use any of these interrupts here on the left. Okay? Nothing else. If you're doing timer 0 is the same, port B change is the same, external peripheral, you add this enable. Right. Where are the other enables for timer 2, timer 1, analog serial communication, transmit or receive? We have two new registers. Well, actually they are 4. بس split into. في register اسمها, let me tell you the register names. PIE, E enable. PIR. هاي للenables. And the PIR is for the flags. تمام؟ So شوف الترتيب كيف تاعهم. So if we have a register, خلاص, this is a register that is present. It's a special function register موجودة in the RAM. Okay. PI1 اسمهم 1. PIE1 PIR1. هيهم. bit 0 هون بالPIE1 هو is the timer 1 interrupt enable. بالPIR1 in the same location bit 0 is the timer 1 interrupt flag. Okay. Timer 2 in PIE1 bit 1, this is the timer 2 interrupt enable. If we were talking about PIE1, timer 2 interrupt enable. And the flag for timer 2 interrupt is in the PIR1, same location. And so on. CCP1, synchronous serial communication, USR transmit, USR receive, analog digital converter, and parallel slave. How many interrupts did we cover here? 8, صح؟ لأنها 8 bit. But we say we have 15 interrupts, صح? Here. طيب, these are covered in the intcon. These are covered in the intcon. هلا في 8 of these we covered them in PIR1 and PIE1. The enables in the PIE1, هاي enables in PIE1. بضل flags in the PIR1. طيب, what about the other? They did not fit. The register, the PIE or the PIR is only 8-bit. So we have PIE2 or PIR2, the same concept. عشان نكمل the other interrupts that did not have a place for them here in the PIE1 and PIR1. Okay? So بس هم they're not 8 plus 8 16 وعندي int كان less. So these bits مثلا هذا not implemented. This is not implemented. This is not implemented. Okay, and this is not implemented. So we have 1, 2, 3, 4. 1, 2, 3, 4. 4 enables in the PIE2 and 4 flags in the PIR2. Understood?
دكتور سؤال يعني هلا اذا صار انا بدي to enable timer 1 لازم يعني هلا اول شيء الجلوبال يعني احطه بعدين البريفرال وبعدين
Yes.
انه
Yes.
ضربت الفلاج تاع تايمر 1.
يلا خلينا let's do it. You wanna do it بسرعة؟
والله
So
يا ريت.
يلا let's do it بسرعة. Let me copy this. So let's go. I'm gonna compare between timer 0 and timer 2. طيب لأنهم the same size. So this is the end con. This is the end con. صح? To remember. This is the end con register. When we used to enable the timer 0 interrupt flag جوا main inside the main program, we used to do what? We say end con equals, I want to do global enable, timer 0 enable, صح؟ بس equals يعني هاي 1 0 1 0 0 0 0 0 صح؟ Which is what? A 0 x A 0. Now the interrupt is enabled, timer 0. When I write the interrupt service routine to check if the interrupt, what's bringing me here is the timer 0 interrupt, I check for its flag, صح? I check for this flag if it's 1. So I mask everything else. I AND everything here with 0 except for this with 1. So I ANDed with a 4 0 if int con ANDed with 0x0 4. Then what brought me here is the timer 0 overflow. صح? This is for timer 0 interrupt. Timer 0 interrupt. Right. If we want to do the same thing for timer 1, okay, let me copy this again. Now we have more registers. We have timer 1, we have int con, sorry, and we have the PIE1. Is it timer 1 here? Yes, it is here. Let me copy this. We have the PIE1, PIR1. Put it here. Clear? Right. To enable, so to do timer 2 overflow interrupt, first the enable inside the main program, main function. What do? We need to make this bit a 1. We need to make the peripheral interrupt enable a 1. We need to make timer 2 interrupt enable a 1, which is what? يعني where is timer 2? Here. شايفين هاي? So timer 2 is this bit. We need to make it a 1 في أي register in the PIE1. PIE1. So what do we do to enable? هذه we write in it 0 0 0 0 0 0. So the number here is C 0. So, and the number here is 0 1 0 0 0 0 0 0. right, is what? 2, 0. So we say int con equals 0x C0, صح? C0 PIE1 equals I1 equals 02 0x 02. This is the enable. طيب. The interrupt itself, when it happens, how do I write the interrupt service routine? Inside the interrupt service routine, we need to check if the interrupt timer 2 enable flag, timer 2 flag is raised. So we say if, what is the register that timer 2 flag exists in? PIR1, right? If PIR1, oops, if PIR1 and we need to mask everything else. And the PIR1 exists here, right? We need to check if it's 1 or not. So we end it with, we mask everything, برضو 02. Everything with zeros except for this one. Ended with 0x02. Then what got us here is timer 2. Enter service routine. Clear?
دكتور سؤال.
Yes.
هلا هو نحن اذا عم نتعامل مع تايمر 0 وتايمر 2 لحال، طب اذا انا عم بستخدم تايمر 0 وتايمر 2 مع بعض.
Yeah.
هلا كيف بدي احط انه مثلا يعني مره اروح اعرف انت كان هي 0xa0 بعدين احط بالسطر اللي تحته.
No. يعني okay, I got your question. Let's enable the 3 of them. 0, 1 و 2. شو رايك؟
اوكي.
Okay. 0 we enable it from here. نعمل هذا البت 1. So بدل السي هاي شو بصير هون؟ بتصير اي صح؟
بتصير اي.
بتصير اي. وال1 هاي بدها تصير 1 وال2 هاي بدها تصير 1. تايمر 1 وتايمر 2 صح؟ بدل ال2 هاي بتصير 3. Got it? So بصير الانت كان equals E0 والPIE1 بصير 0 3 وبعدين الانتربت سيرفيس روتين لتايمر 1 هذا تايمر 2 بيصير هيك تعمل اف ثانيه اف PIR2 ended مع 0x01 لانه تايمر 1 is here صح؟ True. Do the timer 1 interrupt service routine. If int con interrupt flag is for timer 0, you know, this one, right? And mask everything else. Heavy 4, ended with 0x04. Then here you write the interrupt service routine for timer 0. So now you have 3 timers running and 3 overflowing at the speed that you decided when you configured the clocks. For the timer 0, the clock is, we configure it in the option register. For timer 1 and 2, لهم registers ثاني. Okay. I hope it's clear.
100 دكتور.
Okay, so these are the interrupts. The new thing in the 16A877A controller. What's left? The parallel ports. يا جماعة يعني simple. I need to finish this. خلاص, we're done يعني. In the 16F874A controller, we had only port A, right, and port B. تمام? Now here we have port C زيادة بال 77A. The 77A we have port C زيادة extra. It is an 8-bit. So port A was 5-bit. Port B was 8-bit. Port C is 8-bit. Some of it spins. In the 77A controller, port A was pure digital port. Port B was digital port. In the 77A controller, A can be configured to be digital or analog. And we spent all last night talking about what is digital and analog, right? If you're curious to know, go watch the recording of last night. I didn't upload it yet. طيب. Port C is a digital port. Some of its pins are shared with the serial communication. طيب. Oh, by the way, port A was 5-bit in the 84A. Now it's 6-bit in the 77A. طيب. Port A is shared with the analog digital converter. I say analog digital, and we see how we configured the port to be default is analog. The default for port A in the 77A controller is analog. So you cannot just go say TRISA equals input وبعدين just use port A. No, you cannot do that. You need to go into the ADCON1 register and write in it 0x06. طيب. This will make it digital. ليش 06? I explained this in last night's class. طيب. Then you can start using port A as a digital port. طيب. This is about port A. That's it. This is how it's different. Here the architecture. We looked at the parallel ports. The architecture of the parallel ports. This one has this extra analog input enable. If it's if you're enabled, the port is analog, you disable reading the digital. Okay. If the analog input mode is 1, then this is disabled. So, okay. Then port C we said is new. Some of its pins are shared with peripherals like serial communication. Okay. In this case, when the peripheral is used, هون في OR gate, it overrides the direction register. It overrides the direction register for port C. تمام. إذا في serial communication, you don't have to go say this pin on port C is output or input. طيب. I'll come back to this later. بعدين في 8-bit port D, digital port, exactly as port B. So صار في A, B, C, D. And there is port E, but this port E is 8-bit. 3-bit, sorry, 3-bit. And port E is close to port A. Can be used analog or as digital. Okay? The default for it is analog. Command to make it digital. Command you go write in ADCON1, this one, you write 0x06. تمام؟ بصيروا كلهم digital. Port E command له another use. هلا port A, port B, port C, port D كلهم لهم tri-state buffer TRIS A or B or C or D registers to define the direction that if they are output or input. طيب. Now port E, the register where we define the direction is called also TRISE, but the lower 3 bits, and who are 3 bits? Port E is 3 bits. The other bits in the same register are for other purposes, okay? What are these other purposes? I'm not going to go deep enough. There is something called the slave mode that we can make our microcontroller work in. For those who studied or took the class, the microprocessor class, I think they covered something like this. You can make the 7A controller or the 74A or 77A controller work as a slave controlled by a microprocessor. Okay, so a microprocessor can be handling one microcontroller, another chip, a third chip. Okay, when it talks, the processor has one address bus, one data bus. So when it writes something on the bus, is it intending this for this chip or this chip or this chip? Well, it is controlled by a chip select bit. Then it says, I want to read from you or write to you. Okay, chip select, read, write, chip select, read, write. For our microcontroller, the 16F877A controller, you can use it as a peripheral controlled by a microprocessor. And the 3 bits here are the port E bits. ماشي? The clock select هذه parallel slave port status control bits. These are the bits, sorry, the bits that we use and to control port E. We're done, guys. We're not going to use this controller in this mode. We went more into microprocessors. Last thing in this chapter, and then we're going to finish it. It talks about debugging. And this is going to be handy and very useful in the lab. Before I go into this, and I'm going to finish this and خلص الكلاس, and chapter 8, we'll do it on Tuesday and Thursday, and we will have to finish it. Any questions so far? So to summarize, the new things in the 77A controller are the program memory. It has now pages. We did not have this concept before. The data memory. Now we have banks, data memory banks, 4 banks. We only had 2 in the previous one. Now here we have more interrupts, and a new concept called peripheral interrupt enable is introduced. We are dealing with 15 interrupt sources instead of 4 versus the 4 in 16F878A controller. And the last thing is the ports. We used to have 2 ports, port A and B. Now we have 5 ports, A, B, C, D, and E. Tamam? And these ports, A and E, can be used as digital or can be used as analog to connect analog sensors on them and perform analog to digital conversion. I covered this analog to digital conversion in chapter 11, recorded last night, will be posted soon. Now in general here, when you design an embedded system, you put things together, you work like for hours, you put things together and you don't get the thing you want. You don't get the results you're expecting. And I see this all the time in the lab. And you put the circuit, you write the program, you dump everything together and it doesn't work. And people get depressed, or I don't know what they give up. Oh, it's not working. We need to learn a debugging approach to help us test an embedded system. Okay. So when your microcontroller or your embedded system that you design doesn't work, you start with the very primary basic thing. Is my master clear floating? If it's floating, it could be causing a reset, a continuous reset because of the noise. Do I have a running oscillator connected? Did I program the microcontroller? Did I power up the microcontroller? You check these basic things, one by one. If these are all okay, you move into the next level. Is my design, does it make sense? Plausible? Is it correct to connect this sensor this way with this pin? Am I connecting the sensor that is giving me analog voltage to an analog pin or a digital pin? So, and did I assemble the things right? So you look at the basics here. As your design, is it right to connect the sensor here? Is the program structure look good and look reasonable? Did you enable the interrupt before you use the interrupt service routine? Did you do the proper initialization for the analog digital conversion pins? So the layer 2. Then you go to layer 3. Okay, the program is running, but the results are not accurate. I checked, so you eliminated these. The interrupt is happening, but what's inside the interrupt is not supposed to be doing this. I'm supposed to be incrementing something, not decrementing. Okay, so here you need to go and debug, and we have to debug. You could do single stepping through the debug tools like the ones we used when we use microchip, single stepping, or even you can use hardware tools. يعني scope. أنا personally I always tell the students, and when I walk into the embedded systems lab, they're just there all shocked that their thing is not working. And okay, and I try to help them. Where is your scope? Where is your oscilloscope? They say, I don't imagine anybody designing and debugging an embedded system without an oscilloscope. An oscilloscope is a very helpful tool to diagnose problems. You can use it to check if there's a voltage level somewhere, right? You can check when you come to work with timers, timing. You can, even in your program, you can raise, when I finish these 3 lines, okay, I raise port B to high. You can see it on the scope. Then, I executed the first lines of code. I'm not stuck in the first 4. Let's go check the second 2 lines. You put another pin to high or whatever. You monitor it. The PWM, when you communicate, when you deal with مثلا servo motors, the PWM signal timing is very, very important. This time from here to here, 20 milliseconds, this time from here to here decides the angle. So the servo motor is not turning to the right angle I wanted to. Like, what was the problem? Okay, before was the problem. Go check, is the timing here 1.2 milliseconds, for example, if it was 1.2. Okay, so there are many diagnostic tools that you can use. The most important one is the oscilloscope. Free circuit emulators that can you emulate or simulate something. On-chip debuggers, like when you did the single stepping. And logic analyzers, you can put something on a pin and see if it's high or low. Am I getting the required voltage from this sensor or from this whatever? That's it, guys. That's chapter 7. And it's on time for the first time, 11:10. Chapter 8, chapter 7 and chapter 8 are mandatory, okay? And they're going to be part of the exam. Is about human physical interfaces. Here we're going to go to more practical. Keypads, how do we use them, 7-signal displays, different kind of sensors, motors, servo motors, H-bridges, how do we control the speed and direction of a motor. And I have included some examples here. Any questions? If you don't have any question, I'm going to stop the recording anyways. If you can stay for questions for 5-10 minutes if you want. Thank you very much and see you Tuesday. If we are to have an extra session on Tuesday, I'll send you a notice before. Thank you.